All right, welcome back. This is part three of the series of videos of graphing linear equations. This is also the final part. Part two, we talked about slope-intercept form. You see that written right there. And part three, we're going to talk about general form or standard form. Be familiar with both words. I know in part one I called it standard, and then I wrote general in parentheses. This time I just reversed it. But you need to be familiar with both. So remember, general form is ax plus by equals c, where a, b, and c are integers. Remember, integer is a number that is not a fraction. 2/3, 4/5, those are fractions. They are not integers. Integers are your positive whole numbers, like 5, 10, 12. And then, of course, and then your negative whole numbers, -5, -10, -12, and 0. A is positive. A is greater than 0, so numbers greater than 0 are positive numbers. All right, so we're going to take a general form equation and we're going to graph from it. So let's just start off with something relatively easy. Let's start off with 2x plus 6y equals, let's say, 12. There are two ways of graphing this. One way is to find the x and y intercepts. The other way is to convert to slope-intercept form. Converting to slope-intercept form is not bad. We've talked about literal equations, and that's what we have here. Finding the x and y intercepts, though, could be a little bit more difficult, especially if numbers don't divide evenly into other numbers, because we don't want to find an x-intercept of 2.3. We don't want to do that because we're just not sure where it's going to be exactly. But I'll show you how to do this, do it this way, and then we'll do it this way. And this is probably the way I'm going to do most often. Every once in a while, you'll have to be able to graph by intercepts. Okay, anyway, so as you recall, from about a week and a half, 2 weeks ago, to find the x-intercept, you're going to substitute 0 for y. Okay, that's what we're going to do. So let's take our equation, 2x plus 6y equals 12. Let's substitute a 0 in place of the y. We know 6 times 0 is 0. 0 plus whatever is going to be whatever. So 2x is equal to 12, because 2x plus 0 is equal to 2x. Then we'll divide by 2, and I get x equals 6. That's not bad. That is a good number to find on your x-intercept. Now let's find the y-intercept. And again, as you recall from about a week and a half, 2 weeks ago, to find the y-intercept, you'll substitute 0 for the x. So let's take our equation. Let's take the x and substitute with the 0. 2 times 0 is 0. 0 plus 6y is still 6y. Remember, that's your additive identity that we learned. Let's divide both sides by 6, and I get y equals 2. Okay, I'm going to graph this. Let's see if I can slide this graph in and still see the intercepts. So we're going to graph 2x plus 6y equals 12 using the intercepts. I found an x-intercept of 6. So on the x-axis, let's find 6. There it is. I found the y-intercept of 2. So on the y-axis, let's find 2. There it is. All right, I'll take my ruler and connect the dots. There you go. So using intercepts, we can graph that function written in standard form. And remember though, when I did the division over here, I got integers. I did not get any decimals or fractions. And this is what we want. We want integers if we're going to do it this way. Okay, so the second way that we're going to do this is we're going to convert the standard form equation 2x plus 6y equals 12 into slope-intercept form. Now, if you remember in slope-intercept form, we have isolated the y, or the y is already isolated. Actually, we didn't do it. It was already isolated. That's what we want to do here. We want to isolate that y. So let me highlight it. I will actually highlight this whole entire term because I'm not going to touch it until last. So the first thing I need to do is I'm going to get rid of this x term. No matter what, if there is an x term here, we're going to get rid of it. This is a positive 2x. Its opposite is negative 2x, so we'll subtract negative 2x from both sides. Let's bring that 6y down. Let's bring the equal sign down, and then we're going to write it with the negative 2x first and then positive 12. Why am I writing the x first? Well, because in slope-intercept form, your x term is written first. Also, too, 12 minus 2x cannot be subtracted. They are not like terms. So 12 minus 2x is not 10x. Let me repeat that. It is not 10x. We cannot subtract them because they are not like terms. All right, so let's go ahead and continue. Remember, we want to isolate that y. Let me highlight that y. I can now do something about that 6. That is 6 times y. The opposite of multiplication is division. So we will divide by 6 into everything. Okay, notice what I wrote. We're going to divide that into everything. 6 divided by 6 is 1. They cancel out. Leaves me with the y. Negative 2 over 6. I will go ahead and write that right now. We do know we're going to reduce that. I'll write the x beside it. And then 12 divided by 6 is 2. So let's go ahead and take that negative 2 over x, and let's go ahead and reduce it. Now remember, you can do that with your TI-83 or TI-84 simply by typing in negative 2 divided by 6, hit the math button, then hit enter twice. That gives us negative 1/3. So negative 1 over 3x plus 2. Now let me rewrite that down here. Y equals negative 1/3 x plus 2. That is my slope-intercept form of this graph. I will go ahead and say that you sometimes will see this written like this. They're both the same thing, all right, with the x up top in the numerator. All right, so just be familiar with that. All right, so let's go ahead and graph negative 1/3 x plus 2. Let's analyze that. Our slope is negative 1 over 3. It's already fraction. We do not need to convert it. Our y-intercept is a positive 2. Also keep in mind the 1 is negative. That's my rise. That means we'll go down 1. My 3 is positive. That's my run. We'll go to the right 3. So let me get my graph paper. I'm not going to be able to, let me just rewrite the equation right there. All right, so here's my equation, negative 1/3 x plus 2. My slope is negative 1 over 3. We will go down 1, right 3, and my y-intercept's a positive 2. Okay, so my y-axis for my y-intercept at positive 2, positive 2, positive 2. Put a point there. My slope is negative 1 over 3, down 1, right 3, down 1, right 1, 2, 3. Let's do it again. 1, 1, 2, 3. One more time. 1, 1, 2, 3. So I have 4 points there, and I will connect with my ruler. Okay, so that is how we graph from standard form. One thing I will do is I will go through an example of a problem where we do not want to use the intercepts. All right, so let's say that we have, and I'm just kind of making this up, 2x minus 3y is equal to, let's say 8. Okay, that would be better, 8. No, 8 is not going to be a good number. Let's make it 9. Okay, that might be a little bit better. All right, so if I try to find my x-intercept, remember we will replace the replace the y with a 0, and we'll have this. We replace the y with a 0, we substituted, this is equal to 0, 2x minus 0 is still 2x, is equal to 9, x, and divide by 2, I get x equals 4.5. Well, 4.5, I'm pretty sure I know where 4.5 is, but this is one of those situations where I get a decimal and I don't want to have to estimate where that 0.5 is. So this is that situation where we will not use the intercepts. And all you got to do is just check. You know, take the constant out here and divide it by each number. If you get a decimal, don't do it this way. Go ahead and convert it into slope-intercept form. So let's subtract 2x from both sides. I get negative 3y is equal to negative 2x plus 9. Remember, we're writing the x term first and then the constant. And then let's divide by negative 3. Negative 3's cancel out. I get y equals, now negative 2 over negative 3 gives me a positive 2 over 3. That's already reduced. Bring the x down beside it. 9 divided by negative 3 is a negative 3. Okay, that's what we would do. All right, so now this is the end of part 3, and you will have a few problems to work on after you have viewed the videos. Okay, good luck with them, and as always, let me know if I can help out.